Ada sih.
Ada ya. Okay. Physical ke online?
Online.
So then tak perlu rushing sangat lah. Okay. So today we continue with chapter 8, which is about physical optic. So previously what we learned is about geometrical optic, which is we discussed about ray, mostly about ray plane direction and things like that. But today we would like to discuss about the physical properties of the optics itself. So this is quite a long chapter, panjang sikit, tapi tak ada panjang sangat. So it consists of 6 subtopic, and I think the marks allocate for PSPM is similar with the geometrical optics. I think it's about 10 code kalau if I'm not mistaken. So for today, hopefully we can cover from Huygens up until thin films. Okay, so we learn about Huygens principle, about constructive and destructive interference, how does it work, and then about young double slit, as well as thin film. Okay, so these two is basically discussion on interference. So actually, these two is about interference, and these two is about diffraction. So we will learn about the principle of interference and how the wave actually move first, and then afterwards we go through the phenomena of interference. Okay, Huygens principle. Huygens ni actually dia bukannya seorang physicist, dia actually adalah mathematician, and dia punya principle ni actually describe motion of a wave. It does not limited to light, but the light, since the light is the wave, so you can apply the Huygens principle for light as well. Okay, Huygens, saya flip ini ni lah. Huygens state that every point on a wave front can be considered as a source of secondary wavelets, okay, that spread out forward direction at the speed of the wave. The new wavefront is the envelope of all the secondary wavelets. Okay, ayat ni macam panjang. So normally kalau dulu dia selalu tanya pasal tu lah. Sekarang ni dah kurang sikit dia tanya pasal Huygens ni sebab mostly dia dah tanya dalam objektif. Saya tarik ni dulu. Okay, basically Huygens want to describe how the wave actually move from one position to another position. Okay, contohnya this is your wave front. Wave front ni basically your bentuk wave tu itself lah. It can be circular wave. So yang ni dia macam straight line je macam tu. Tapi notice dekat ujung ni dia ada corner sikit macam tu. Ada edge dia tu, dia lengkung. So we know that this wave will travel in this direction. Let's say this wave is traveling in this direction. That's the values of v. Okay. According to Huygens, every point on the wavefront, this is the wavefront, every single point on it can be considered as a source of secondary wavelet. Wavelet ni anak-anak secondary wavelet lah. So kamu boleh imagine wavelet ni macam kamu baling batu dekat dalam water. So it will create the ripple. Tapi notice that here dia kata dia spread out in forward direction sahaja. So kalau ripple yang kamu baling kat dalam water tu dia akan circle kan. Tapi yang ni dia forward direction saja. So it will create a wave like this. Okay. And the new wavefront yang baru tu is actually tangential to the secondary wavelet. Dia cakap ini macam envelope of all the secondary wavelet, tapi basically dia adalah tangential to the secondary wavelet ni lah. So tangential as if something like this. Okay. Tapi remember dekat hujung dia ada macam circular sedikit saja. Okay. And this process dia continue. Because it's spread out with the same velocity, the new wavefront will have the same velocity as well with the original wavefront. So this process they continue and dia akan so okay, tak boleh I give up already. So this process will continue and will create more and more wavefront. So eventually you will see that as if the wavefront actually move forwards. And memang dia move forward pun, tapi this is how it travels. So far ada soalan ke tidak?
Tak ada, sir.
Tak ada. So Huygens ni dia basically describe macam mana wavefront tu travel, macam mana wave travel. And dia sebenarnya describe tak semestinya pasal cahaya. Dia actually describe for all types of wave. Tapi for our syllabus, for this chapter we focus on optics, so lights lah. But for drawing purpose macam yang saya lukis ni, maybe kamu boleh bayangkan dia sebagai water. Senang sikit nak bayangkan. And in fact, sometimes dia tanya dalam soalan, they ask you to draw. Okay, what if your wavefront now hit an obstacle? Wavefront tu bertemu dengan penghalang lah. So again, if I want to draw, let's say that the original position of my wave is over here. Okay, and then dia berlanggar dengan obstacle. So dia terputus lah. Dia masa langgar tu dia tak adalah nak kena the Huygens. So masa keluar tu yang kamu apply the Huygens. So soalan ni biasa cukup macam ni. Apply the Huygens principle and try to draw the wavefront punya motion. So let's say the direction of velocity is in this direction to the right. Okay, what will happen over here? On the wavefront akan ada wavelets. And this wavelet is the source of the new wavefront, and the new wavefront will always be tangential to the wavelet punya ni. So you will have a new wavefront which is something like this, dia terputus, and then dia akan create lagi like this. Again, make sure kamu lukis stage kat ujung tu, dia macam melengkung sikit. Okay, kamu boleh lukis tak macam ni? You guys understand or not? How to draw? Are you guys still there? Masih bersama saya ke? Okay tak ni?
Okay je, sir.
Senyap je.
Yes, sir.
Okay. Example number 2. Okay, example number 2. Dia ada obstruction, tapi dia dekat left and right of the wave. So this is your wavefront. So dia hit the obstacle. So yang langgar tu dia mati gitulah. So yang terhasil is actually from the new wavelets tu. And the source is actually over here. This. Okay, again, kita draw the wavelet. Banyak sangat pun tak apa. Okay. And then the new wavefront will be over here. Oops. Okay. Okay, kalau kamu perasan saya lukis tu dia ada macam mengembang macam ni kan. So dia memang dia punya behavior tu memang macam tu lah, sebabnya dekat hujung ni ada wavelet, dia produce yang ke situ. Sebab tu dia macam ni. So memang kamu kena lukis macam ni. Make sure dia mengembang balik lah, macam saya lukis kat sini and over here. And the last one example, masih lagi ada obstacle left and right, but this time what will happen if you have a very small space separation between the two obstacles tu very small. So if that one is very small, you can only produce one wavelet ke belakang macam tu lah. So as a result, you produce a spherical punya wavefront. Dia dah bertukar type daripada square jadi spherical. Okay, you guys clear with this?
Saya nak tanya.
Yes, boleh?
Kalau macam dia suruh lukis kan,
Ha,
tu kena tunjuk juga ke wave yang kecil-kecil tu.
kena. Ha, sebab dia kata dia biasanya dalam soalan lah dia kata apply the Huygens principle. Kalau kamu lukis yang biru ni kan, dengan lepas tu yang hasil ni terus, maybe kamu dapat satu markah je. Yang satu markah tu dia nak tengok kamu lukis wavelet tu, walaupun kita dah tahu kan, tapi kena buat juga. Melainkan dia tak cakap dalam soalan lah, tak perlu guna Huygens, tapi to be safe pakai je lah. Okay. Okay, now. So 8.1 tu tak ada apa pun. There's no calculation. At most, dia boleh tanya, they ask you to state Huygens principle. I think that one will be asked in chapter 1. And then maybe, in UPS. And maybe they will try to give you question like this lah. They ask you to draw. Ini paling banyak dia boleh tanya lah. Okay, 8.2 is about interference. How does the interference actually occurs? So based on the name itself, we have constructive, destructive interference. If you want to take the definition for each of these terms, constructive is basically reinforcement. Okay, constructive interference means reinforcement of two amplitude. Amplitude tu dia reinforce, dia jadi more, dia increase. Destructive is cancellation of the amplitude. So the magnitude of the wave actually cancel each other. So dia jadi destructive lah. This one I think you already learn in school pun. So I think you get the ideas. This is just some basics. Interference is the interaction between two or more wave. It doesn't have to be limited to two wave. It could be more than two wave. Okay, but yang ada benda baru sikit yang kamu tahu is about condition or interference. So interference will always occur as long as dia ada more than two wave ni kan. Kalau dia berlanggar dia memang occur. Tapi untuk nampak dia punya fenomena, dia ada condition dia. Kalau tak, interference tu tak nampak. Walaupun dia berlaku kan, the effects yang constructive dan destructive ni kita tak nampak. So to observe this effects, dia ada syarat dia. Number one, coherent light. The light must be coherent. Ataupun, the light is coherent because we are talking about lights for this chapter. And then roughly the same amplitude. Okay, I'm going to discuss roughly the same amplitude first. And for explaining purpose, maybe you can imagine wave yang macam ombak air, water punya wave. Contoh okay, if we have two wave, one wave is very big, macam tinggi dia maybe dalam 3 tingkat punya building, and then kita ada lagi satu wave yang tinggi dia maybe tinggi kamu, and it's about 150, 160, 170 punya centimeter. So these two wave they collide. Will you see this wave tiba-tiba naik double? Adakah kamu akan nampak dia naik yang mendadak? Ataupun dia tiba-tiba fade out because of these two wave made up? Nampak ke tak? Kamu, okay, mana, adakah kamu terlelap? Apa yang sejak hari ni? Saya tengok siapa dia? Mati dah ada?
Ada saja.
Ada. Mati dah ada.
Baiklah.
Amiruddin ada?
Ada.
Ada. Okay, good. Okay, jawablah saya tanya. Adik, saya tanya semua orang bukan seorang-seorang, saya tanya semua orang. Kalau kamu ada satu wave that is really really big, kamu bayangkan macam air lah. And then you have another type of wave that is really really small. dia berlanggar, adakah kamu nampak dia cancel out ataupun dia increase? Can you see the effects?
No.
No, ada pemberat akhirnya. So, bila satu besar sangat, satu kecil sangat, yang kecil tu dia tak main peranan pun. That's why, if you want to see the interference punya effects tu, dia punya amplitude mesti roughly the same. So, yang ni dia tak nampak lah. So, that's why one of the condition is roughly the same amplitude. Itu syarat pertama. To see the effects of interference. Syarat number 2 is coherent lights. Okay, now we focus on the light itself. Jangan fikir ombak lagi lah. We focus on the lights. Okay, we need to have coherent ni maksudnya ada dua maksud. Tadi ni syarat untuk interference, coherent dengan amplitude. And then coherent ni ada dua syarat lagi. Number 1, lambda dengan frekuensi must be equal. Ini bila light tu coherent, syarat ni memang valid lah. So maksud lambda equal, maksudnya kalau saya ada wavelength panjang macam ni, dia kena interference dengan something similar with that. Exactly the same. Kalau dia macam ni dengan macam ni, dia tak nampak efek dia sebab satu panjang satu pendek. So dia tak boleh ada constructive and destructive interference. Frequency is the same. If you have small frequency, you will expect that the wavelength to be really, really small. Dia pendek kontak macam tu. And then another part is delta phi is constant. That one is actually phase different. Phase different maksudnya berapa jarak antara satu wave dengan another wave tu, adakah dia gerak serentak ataupun dia lambat sedikit. Contoh let's say this is my first wave. Kalau dia bergerak serentak, means that dia macam ni lah. Okay. Kalau dia tak bergerak serentak, let's say dia ke depan sikit, dia macam ni. You can still see the interference. Masih boleh nampak. Okay, this is what we call anti-phase interference sebab dia out of phase kan. But, remember, walaupun interference ni boleh nampak, syarat dia dekat sini, the difference must be constant. Dia tak boleh sekejap dia macam ni, sekejap dia macam ni, sekejap dia macam ni. Dia tak boleh dia bergerak-gerak. Kalau beza dia pi, daripada awal sampai habis cerita, mesti beza dia pi. This is what it means by constant phase difference. So, the one that I show ni, sebenarnya menyebabkan you cannot see the interference pattern. So, this is the condition tu mesti opposite from here lah. Okay. Are you guys okay with this? Can we proceed?
Yes, sir.
Okay. Again, dulu soalan macam ni dia selalu tanya dekat paper tu. Dia suruh kamu tulis condition. So student have to write lah. But this time I think I expect this kind of questions from dalam UPS, right? Instead of the PSPM. But there's no harm for you guys to memorize or things like that. Okay. So tadi saya ada sebut pasal in phase dengan out of phase. Kalau in phase maksudnya dia bergerak together lah. Kalau out of phase, kamu punya syllabus out of phase adalah by pi. So setiap kali kita sebut pasal out of phase ataupun anti phase, dia mesti beza dia pi. Dia tak beza banyak pun, beza pi je valid. Macam tu je. Okay, ramai student dia salah faham about in phase dengan anti phase ni. Dia assume in phase adalah constructive, out of phase adalah destructive. Okay, salah because for in phase kamu boleh ada constructive, for out of phase kamu boleh ada constructive juga. Okay, dia tak semestinya in phase. Saya pilih nota. Dia tak semestinya in phase tu hanya konstruktif, dia boleh jadi destruktif juga. Jangan saya cek nota kamu. Mana dia? So ni chapter 8. Because I actually want to show you something. Saya tak sempat nak letak dekat dalam nampak muka saya. Internet slow lah. Actually, I wanted to show you the reason why we have in-phase dengan anti-phase punya interference. Kalau lambat sangat, okay. Gue nak cakap lambat sangat. Okay, so this one is actually comes from your lecture notes. I just want to show you about in-phase and anti-phase. Okay. Okay. The next topik yang saya nak discuss ni sebenarnya dia tak ada calculation. Sometimes they will ask you to calculate delta L, but jarang lah dia suruh. Dulu dia suka, tapi right now I don't think they will ask. Tapi kalau dia tanya, you can straight away use the formula. Jadi saya pergi balik ke formula dia. But I want to focus on the jalan cerita first. The path different. So the path different actually comes because, macam mana saya nak tunjuk pointer tak? Okay, macam kelakar lah actually. I don't know what happened. Okay, tak apalah. Instead, maybe saya kena buat saya nak tunjuk kamu, tapi saya punya pointer ni tak keluar, so kamu tak nampak saya tunjuk apa. Okay, tak apalah, cerita je. Okay, kamu nampak tak delta L dekat bawah tu, dekat bawah tulisan figure 8.12 tu, dia ada delta L. Okay, the delta L comes because satu tu dia keluar daripada bawah, satu tu keluar daripada atas. So that is the path different. Dia memang based on the diagram, you can see delta L tu sentiasa wujud, dia mesti ada. Okay, this is what delta L is about lah. Okay, so macam saya cakap, dia ada in phase dan ada anti phase. Okay, this is the example of interference of two coherent source. Coherent ni maksudnya wavelength dia sama tadi, frekuensi sama dengan phase difference dia sama. You can see that this one is in phase. Memang nampak dia in phase. Satu tu naik, satu tu pun naik. Satu tu turun, satu tu pun turun. And at point P, dia bertemu together. That creates a maximum. Okay, contoh. Okay, this one is example of disruptive interference tapi still in phase. Dia masih lagi in phase, it's just that bila dia heat up, bila dia bertemu, dia disruptive, dia jadi minimum. So they cancel out, you get a flat line like that. Okay, this is example of antiphase. Okay, kamu boleh tengok in phase dan antiphase tu, kamu tengok masa dia keluar. Masa yang ni, saya rasa saya copy lah, saya geram dalam dia ni. Tak boleh nak tunjuk kat kamu. Excuse me. Okay. Saya nak buat tadi, tapi lepas tu terganggu dengan kerja-kerja lain. Saya lupa nak tak. Itu salah chapter. Wah tu. Semalam saya cuba lukis sendiri, tapi lukisan saya tetap cantik. So, dia macam make it worse. Okay. Kamu masih bersama saya tak ni?
Masih, sir.
Masih
Masih.
ke?
Okay. Sorry because I really want you guys to understand this one. Dia sebenarnya tak susah, but then kalau kamu tak faham dia jadi macam susah lah. Tapi sebenarnya dia senang dia. Okay. Done. So I have to do it again. And done. Okay. So, if you want to determine whether it is in phase ataupun out of phase, you can see it from the starting point tu. So, starting dia naik, turun, naik, turun. Both of these has the same behavior. So, these two is actually in phase. Wave number 1, wave number 2 is in phase. And dekat sini dia meet up at the same naik turun juga. So, this is why you have in phase. And this is constructive. Okay. And yang bawah ni pula, dia masih lagi in phase, dia gerak sama-sama. Tapi bila jumpa ni, dia opposite dah. This is why we call destructive. Tapi for in phase. And this one is example for anti-phase. Because you can see that bila dia keluar, satu ni naik atas turun bawah, satu ni turun bawah naik atas. So, this is clearly an anti-phase punya wave. Same with this one, anti-phase. Dia opposite kan. Cuma satu tu konstruktif, satu tu destruktif. Yang atas ni konstruktif because they still bertemu together. So, konstruktif. While below here is destruktif. Okay, sebenarnya saya nak tunjuk in phase anti-phase ni yang kat depan ni. Okay, so asalnya macam ni. Hasil dia gini. Destruktif. Untuk anti-phase, konstruktif untuk anti-phase. And this one is example for in phase, constructive and destructive. Kamu faham ke tidak? Hopefully faham lah berbaloi saya kopi tadi tak sesi. Okay, back to the equation. Macam saya cakap lah, dia jarang tanya tapi dia boleh tanya. Kadang-kadang dia suka kira path different tu. So, they will give you values of m. M is numbers of order. They will give you lambda. You simply have to substitute inside the formula. But, the formula ni dia tak beri dalam exam. So, you have to be careful lah. Maybe dia beri tapi tak cukup word. You have to be careful with m plus half dengan m ni. Okay. Saya biasa hafal yang in phase. Sebab, yang double slit adalah in phase punya interference. So, I will memorize satu part, one side, and the rest yang out of phase ni akan datang sebab saya hafal yang satu tu lah. So, as a result, I will see this formula as opposite to this one. So, in phase ni, constructive M, destructive M plus half. For out of phase, dia terbalik. Constructive M plus half, ini adalah M. We will learn this equation more in thin layer dengan yang double slit. Okay, kita proceed ke yang double slit. Yang double slit is actually a very simple experiment. So, dulu, when Young tried to do the experiment, he want to see the interference pattern tu. So, dia nak create satu eksperimen. To create the Young double slit experiment, untuk nampakkan interference pattern tu, syarat dia adalah coherent light. So you can imagine kalau dulu-dulu kamu nak produce coherent light, itu bukan senang. And basically you need to have light with the same lambda, same color lah, and then you need to have the same phase difference, everything semua kena sama. So yang buat dia basically pakai satu source dia. So if the light source is the same, you will expect it is a coherent light, kan? Memang punca dia sama, hasil dia sama lah, coherent light. So apa yang dia buat, dia letak dua slit in front of the uh, light source tu. So light source tu dia maybe produce a wave like this. Tak kisahlah wave dia bentuk macam mana. Tapi bila dekat slit tu, dia hanya create satu dot yang tu, and then they create a spherical punya pattern. And this spherical pattern akan ada overlaps and interference lah. Basically they will overlap, produce interference, and you can see the interference pattern on the screen. Okay, so basic quantity like the d small d ni biasanya nilai dia small, maybe cm, maybe mm, and that is the distance between the two slit. Okay, actually this light sebab dia memang datang serentak, so source dia ni adalah in phase tau. And then kalau dia produce konstruktif, dia konstruktif lah. Kalau destruktif, dia destruktif. Tapi dia in phase. And the D is the distance between the slit and the screen. Okay, we used to have this experiment dekat lab. So dulu best. Boleh tengok dalam lab lah. See bersama. Okay. Again, macam saya cakap lah, I think kamu punya syllabus more and more dia akan tanya pasal calculation. Dulu dia banyak tanya teori, sekarang dia dah kurang sikit sebab dia banyak masukkan dekat dalam UPS. So again, calculation is the most important thing. This is where all the marks is given. Most of the mark is given. So I want you guys to understand few things lah. The formula is ym m lambda d over d. Okay, d ni saya dah sebut apa dia. Lambda is the light source punya lambda. Ym is the distance between the central or the maximum towards the certain m tu lah. Kalau dia kata m tu untuk bright tu, so maksudnya from here to here. Okay, kalau m sama dengan 2, this is the y2 punya values. And then for destructive interference, m dia tu dia tukar m plus half. Mana datang m dengan m plus half ni, dia sebenarnya datang daripada path difference tadi tu, yang ada m dengan m plus half tadi. Sama, dia sebenarnya ada derivation lah, tapi saya tak perlu tunjuk derivation. So you end up like this. This is the familiar equation that you use in school. Memang sebiji sama. Okay, cuma maybe yang bawah ni kamu tak biasa pakai kot. So the delta y is the distance between the two consecutive fringes. So that means between 1 and 2, or 0 and 1, or 0 and 1. Okay, that is your delta y. It represents the shape of your pattern. So this is what we call the interference pattern. The key criteria dia adalah the size of the pattern adalah sama. You have the same pattern lah. Kalau yang tak sama ni sebab saya lukis yang sikit kot. Tapi sepatutnya dia sama. And here I represent black and red. So kalau dia black and red, maksudnya yang black tu adalah destructive. Basically dalam exam, dia akan warnakan hitam. Jadi yang red ni dalam exam, biasa dia lompongkan. Dia tak ada colour lah. Exam kamu mana ada warna kan, dia black and white. So yang white tu ataupun yang sekarang saya pakai red adalah constructive. And kenapa dia red? It depends on the light source punya light. Okay, yang dekat sini lah. Kalau saya pakai blue, obviously saya nampak blue and black. Kalau saya nak pakai red, and then I will see black and red. Okay, the constructive tu bukannya white dia sebenarnya ada warna. It depends on the wavelength. Itu yang saya nak faham lah. And yang black tu, kalau kamu buat kat tempat gelap, dia jadi gelap lah. That means there's no light over here. Okay, one of the most important thing yang selalu student salah when they try to use this formula is when they try to substitute values of m. Okay, remember this M dalam exam kadang-kadang dia kasih nilai M. M ni adalah numbers of order. So if the question gives you numbers of order, you can straight away substitute inside this equation. Tak ada masalah. M, kita kata second order. Calculate the distance Y for second order. Masuk je M sama dengan 2. Calculate the destructive for M equals to 1. Masuk je. The problem is, if they give you fringes. Dia kasih fringe. So contohnya here, yang middle one ni dia panggil sebagai central order maximum. So yang this one, yang here is basically your first bright fringes. M sama dengan 1. Second bright fringes, M sama dengan 2. So tak ada masalah. For bright fringes ataupun constructive interference, if they give you number of fringes, you can still substitute inside here straight away. Tapi for dark fringes ataupun destructive, okay, here dia masih lagi dipanggil sebagai central order maximum. Over here is actually your first dark fringe. Atas dengan bawah here is your first dark fringe. You will see that the M is equals to 0. Okay, yang atas ni, yang bawah ni is actually second dark fringe. But the M numbers of order is 1. So dark fringes dia mesti sentiasa kena minus 1. So I'm going to write over here. So fringes minus 1 is actually the numbers of order. So when you try to substitute for destructive interference only, if they give you numbers of fringes, you have to minus 1, then you substitute inside the equation. Okay, so sebab soalan dia tak susah, paling susah, paling tricky dia nak buat, ini je lah yang dia mampu buat. So please be careful, and memang dia buat macam ni lah. They will give you numbers of fringes most of the time. Ada soalan tak?
Sir, so maksudnya dekat ujung tu third dark fringes lah.
Ujung dah. So first dark fringes, second dark fringes, yang this one yes, third dark fringes. Sebenarnya pattern ada banyak lagi lah, tapi saya stop kat sini je. Okay. Can we proceed? Okay.
Boleh sir.
Boleh. So from now you can try to do the question or the pasir lah. Boleh cuba tengok M kamu tu okey ke tak. And then dulu favorite question dalam pasir dia suka tanya what will happen when lambda is increased. What will happen when the D is increased, capital D, small d is increased. So they want you to discuss the pattern punya bentuk. So if you want to discuss about pattern, you can only use this formula to discuss. Nak pakai formula lain boleh, tak ada masalah. Tapi biasanya kita pakai formula inilah untuk describe the pattern. So contoh dia kata what will happen when the slit is being brought closer together. Slit tu didekatkan. So when D is decreasing, you will see that delta Y is increasing. So if you want to answer this kind of question, you can write lah from equation delta Y blah 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 blah. Okay, delta Y is inversely proportional to D. So when D is increase, delta Y is decrease. Tapi kalau kamu leave it like that, dia tak cukup. Delta Y decrease means the pattern become narrower. So interference pattern ni dia jadi mengecut. Size dia pun mengecut, dia kurus. Kalau Y dia tu dia gemuk lah, dia makin besar. Okay, nanti kalau kamu jumpa soalan kamu nampak kot. Okay, yang last ni is about, yang last yang saya nak masuk today lah, is actually about thin film interference. Okay, dia masih lagi bawa interference. Dia masih lagi about light interference. Cuma thin film interference ni dia boleh in phase, dia boleh anti phase. Okay, kenapa? interference dia sebenarnya macam ni you have different medium. Okay, when light tries to move inside a different medium, dia akan refract sebenarnya apa I think pembelawan tak pembelawan, refract saya tak ingat refract apa. So dia akan refract, dia sama ada dia akan brought closer to the normal ataupun further away from the normal. Kamu ingat kot ni bila dia ada different medium. Tapi dekat sekolah dia tak tekankan about reflected lights. Okay? Dekat sekolah kamu belajar refracted, tapi kamu tak discuss pasal lights yang reflected. So you can safely assume semua permukaan yang kita nampak ni sebenarnya pantulkan cahaya, except dekat black body lah. So black body dia memang tak pantulkan cahaya ataupun black hole. Contohnya kamu tengok dinding macam kat sekarang ni, dinding kat belakang saya ni, you can see that dia colour orange. Dia sebenarnya dia pantulkan colour orange, yang colour lain tu dia serap. Itu konsep lah, sebab tu kamu nampak colour orange. So this one you can see that ada, when it hits the first surface, dia reflected separuh, tak adalah exactly half kan, tapi dia reflected dengan refracted. Okay, and then bila dia enter the second medium, dia ada reflected as well. So these two reflected lights, dia interfere dekat sini, dia bertemu balik. So bila dia bertemu balik, dia akan create constructive or destructive interference. Okay? But you have to identify ini sebagai your source. Kalau tadi yang double slit, kita pakai source dia macam ni kan, and then dia sama ada in phase or anti phase. Tapi kalau yang double slit dia sentiasa in phase sebab light source dia sama. But here they could be macam ni and they could be macam ni. So kalau macam ni dia dah anti phase. Again, for in phase and anti phase, dia boleh create constructive and destructive. Remember that. So how do you want to determine in phase or anti phase? You have to determine whether over here do you have a phase change or not, or over here do you have a phase change or not. Kita akan discuss that lagi lah, don't worry about that. And then bila dia interfere, dia akan create constructive and destructive interference. Okay, example for thin film interference. By its name, nama dia pun dah thin film kan. So the surface yang very thin. In fact, yang N2 ni, yang T ni is very small, biasanya millimeter, at most millimeter. Centimeter pun dah too thin atau too thick. So they're less than that. Example dia adalah water bubble. Okay, you can see that water bubble tu sebenarnya lights yang datang dia tu adalah white lights. Cahaya daripada matahari, cahaya biasa, cahaya putih. But then bila dia hit the bubbles tu, you can see as if dia ada banyak warna. It's very pretty soap bubble. Okay. The reason is because the refractive index of the soap. And then another example is like the disc here. This one is a coating layer on the surface. So to prevent scratches from the laser dengan dia punya mata yang nak baca disc tu, dia actually covered in a thin layer CD ni. Kita tak tahulah, biasa kita pakai je kan. Saya tak tahu kamu pernah jumpa ke tak CD. Hopefully kamu pernah jumpa lah. So they cover with the thin layer, coating. Sometimes they cover dekat lens. Ada yang example biasa pakai is either lens ataupun this one lah, soap bubble. Okay, itu example. Kita pergi tengok details for that example. Contohnya untuk soap bubble. Okay, soap bubble ni walaupun kamu nampak dia bulat, kamu boleh bayangkan belah dalam bubble tu actually ada air. Bukan air, ada air. So here is air, outside is air. And the soap bubble itself is basically just a water. So the refractive index here, kalau dia tak beri, you have to use water punya refractive index, which is 1.33. Luar ada satu, dalam ada satu. Boleh ikut ke tak ni untuk soap bubble situation dia?
So far so good, sir.
So far so good. Tapi bila kita nak lukis balik, kita tak perlulah lukis dia macam sphere ke, macam bulat ke. You don't have to. You just have to focus on this part dengan atas bawah. So bila kita nak lukis, biasanya kita set pandang ini kan. So the first thing that you have to do is that you have to draw two lines. Lukis dua line. Tulis T dia tu kat mana, thickness dia tu kat mana. Thickness ni, thickness yang tengah ni. And then you write all the refractive index. Okay, contohnya N1 adalah air, so 1. N2 actually adalah water, 1.33. Inside the bubble is basically the air again. So dia ada 1, 1.33 and 1. Okay, this is how you draw the diagram. You don't have to draw circle ke apa Yang kat tepi ni saya nak tunjuk kamu. This one I just want to show you. Okay, another example, lens coating. Dekat luar ada air, inside the air, bawah sekali adalah glass, dia ada glass. Ni kalau lens ni coating lah, dia ada glass, lens tu itself. And then dia letak coating dekat atas dia. And then ada air. Dia sometimes dia pakai non-reflective coating, sometimes dia pakai reflective coating. It depends on the question lah. Kadang-kadang cermin yang dekat building tu, kan ada tinted yang coating punya reflective tu. Itu pun dia boleh kasih example. You have to read carefully. Application dia, coating tu untuk reflective ke non-reflective. You can see the lights or you cannot see the lights. Kalau you can see, that means dia adalah constructive. Kalau you cannot see, dia adalah destructive. Okay, some student dia confused. Dia kata, you can see purple ataupun dark blue punya color wavelength. So dark blue ni walaupun color dia gelap, dia still ada color. So dia still ada light yang reflected. Dia kalau tak, dia tak ada light. So as long as dia ada any color, dia actually adalah reflective coating. Kadang-kadang dia tak cakap directly lah, that one is non-reflective ataupun reflective. You have to read subtle sikit lah. So the only problem with thin film interference is that student kadang-kadang tak faham bentuk situation tu macam mana, example tu macam mana, and then secondly dia tak tahu soalan tu nak constructive ke destructive. Before you can determine whether it's constructive or destructive, you need to determine whether they in phase ataupun anti-phase. So I'm going to show you the easiest way to determine the in phase and anti-phase. Kamu lukis line macam ni, kamu label N1, N2, N3 ni with the values, and then kamu tengok kalau nombor dia menaik atau menurun. Tiga-tiga ni menaik atau menurun dengan cantik, dia adalah in phase. Contoh workshop bubble ni, dia naik. And then from 1.3 to 1, dia turun. So dia tak cantik kan? So this one is anti-phase. Nombor dia tak berturut. So saya tulis kat sini ya. If not in sequence, it is anti-phase. Kalau dia in sequence, dia adalah in phase. Okay, contoh yang coating tadi. Okay, let's say if you have a lens that made up by the glass, so 1.52, maybe the coating is 1.45, and then the air is 1. Okay, I want to ask you guys, is this in phase or anti-phase punya interference? Adik-adik in phase atau anti-phase?
In phase.
In phase because nombor dia berturut. Dia tak semestinya menaik lah, dia boleh menurun juga. Kalau nombor dia berturut, okay. Dia tak perlulah tambah 2. It just as long as the is in sequence, itu adalah in phase. Kalau not in sequence, dia adalah anti-phase. Okay. Ini cara nak hafal. Once kamu dah tahu benda tu, you can straight away use the formula. Formula for in phase, dia still ada constructive dengan destructive. Formula for anti-phase, dia still ada constructive dengan destructive. So the difference is dekat M ni. Kalau in phase, constructive M. Kalau in phase, destructive M plus half. Sama macam yang double slit. Kenapa? Because yang double slit adalah in phase punya interference. This one anti-phase, so dia terbalik daripada yang double slit. So biasa saya akan hafal yang double slit. Plus yang double slit equation tu diberi dalam exam. Cuma dia tak cakap dia constructive ke destructive lah. So you can use that one as a reference. This one pun diberi formula dia. Cuma dia tak cakap whether this one is for in phase, anti-phase or constructive or destructive. Okay. Sometimes the question want to find the smallest t. T ni dia thin layer tu. So how small can it be? You have to substitute the values of M ni, yang N ni yang kat tengah tadi tu. M ni adalah nilai yang kita nak letak lah. Kalau nak minimum, you just put the minimum value here. Kalau dia boleh letak 0, letak 0. Contohnya dekat sini dengan kat sini, you can put 0. But over here and over here, you cannot put 0. If you put 0, the whole thing becomes 0. Your T becomes 0. So, put this one as 1. Yang dua ni letak sebagai 0 to find the T minimum. Okay or not?
Okay, sir.
Okay. Itu penggunaan formula lah. Penggunaan formula is the most important thing. And you can only learn by doing the examples and tutorial questions and past year. And so, try to do it first. And kalau sempat, maybe tomorrow kita okay, maybe tomorrow kita akan discuss sedikit example lah about yang dah bersih dengan thin film. Kita saya nak sebut satu je lagi. Ada lagi 2 minit kot. Okay, so formation of thin film interference. Tadi saya suruh kamu simply use sama ada di sequence ataupun not in sequence. Tapi dia ada reason dia sebenarnya. Kenapa? Okay, kalau lights tu dia travel daripada lower dense medium to higher refractive index, dia akan ada phase change. Contoh kalau dia travel daripada sini, ni incident ray and then dia nak pergi ke medium here. Dia daripada 1.6 to 1.5, dia menurun. Tak ada phase change. So no phase change. Daripada sini nak masuk dalam ni, menurun juga. No phase change as well. Masa bila dia ada? Bila dia pergi ke denser medium. Contohnya yang ni. Dia masuk, dia pergi ke denser, ada phase change. Undergoes phase change of pi radian. Okay. The second one ni, dia masuk, ni smaller, no phase change. So no phase change. Tapi yang bawah ni dia travel extra 2t lah. Itu tak ada apa pun. Dia masuk, dia keluar balik, so dia travel extra 2t. Tapi kamu kena tulis juga. Dia pernah tanya describe the formation of thin film interference. Dulu dia selalu tanya dekat paper tu. Okay. Sekarang ni pun dia boleh tanya juga. Tak ada masalah. So, macam mana kita nak tahu dia in phase ke anti phase? Kalau dia ada phase change, satu ada phase change, satu tak ada phase change. So, you expect the anti phase lah. Sebab satu tu macam ni, satu lagi macam ni. Memanglah dia adalah anti phase. Kalau dua-dua ada phase change, dia adalah in phase. Contohnya, kalau asalnya macam ni, in phase ni obvious lah. Kalau dua-dua ada pi change, dia jadi macam ni, yang macam ni. It's still in phase. Yang jadi tak in phase tu kalau satu je yang ada phase change. And that satu je yang jadi tu bila nombor dia tak berturut. Itu je lah cerita dia. Okay, saya rasa kita berhenti sini dulu. Okay, kalau yang thin film ni saya akan ulang sedikit lah untuk esok saya akan ulang sedikit, especially buat calculation. And maybe saya akan explain sedikit pasal information ni, saya explain sikit lah. Okay, do you guys have any more question? Kalau tak ada kita berhenti lah pada kelas ni. Okay, senyap. Tu saya